So we are going to look at 4.01, 4.02 today. Polynomial long division, fun stuff there. Remember long division back with just numbers. Now we're going to throw variables into this long division equations. So we're going to do that today. And like I said, I don't think we'll be having any class the rest of the week because I think I'm supposed to be scheduled to have chemo this week and go into the hospital. But the oncologist is trying to figure out if I'm going to be in the hospital, at home, or at his office. I don't know yet. But originally on Friday, he called me and wanted me to be in the hospital tomorrow. So till we know, I will send an email when I get something confirmed on all of that. But it's just kind of craziness right now. It is what it is. All right. So let me put up a camera up here and get this going. Show you what we're studying here in Unit 4. We're talking about polynomial long division. Polynomial long division. And so we are looking at divide. Okay, make sure I'm up there on the camera. So if we're going to divide 2x to the third minus 10x squared plus 18x. And I'm going to divide that by 2x. That looks like the old division problems we did in elementary school, but we got a lot of x's and everything's in there, right? So first we have to look and see how many times does 2x go in 2x to the third. So if you divide that out of there, that leaves an x squared. All right, so x squared times 2x to the third is 2x to the third. Remember, you subtract that. That leaves nothing, 0. So we're going to bring the next term down, negative 10x squared. 2x goes into negative 10x squared, negative 5x times. Because when we multiply those together, we get negative 10x squared. 0. Bring this down. 18x. How many times does 2x go into 18x? 9 times 18x 0. So that means if we take this original polynomial and we divided 2x into it, it ended up with no remainder, 0 remainder. So this is a factor. So we could factor that to be 2x times x squared minus 5x plus 9. So we factored this into these two factors. Now, whether or not that factors to be a different story, you can use the quadratic formula because that's just a quadratic equation now, right? You can use the quadratic formula and figure out if that factors nicely into some lovely factors or if it gets into some imaginary numbers or anything along that lines. But when you divide a term into a polynomial and you end up with a remainder of 0, that tells you that is a factor. That is a factor of that original polynomial. So this will have several examples in the lesson. So here's one where I want you to take 12x squared minus 27x and divide it by negative 3x. So you should do that on paper. You should go through this lesson. It has step 1 through 5. So you can do that and then check your work directly against what they have on theirs. It has another example below that. So there's plenty of examples. When you click those learn mores and other links, be sure and check all of those other links. But this was example 1 right on page 1 of our lesson. So let's see. Let's do this one because this is another type of division that we do with this. Let's say we're dividing x squared minus 2x plus 4. And we're going to divide this by x minus 6. So we're dividing it by a binomial now, a two-termed, two terms in this. So we need to look and see, we start with this biggest number. How many times does x go into x squared? Well, it goes in there x times. I'm going to put it over here. So x times x squared minus 6 is x squared minus 6x. We multiply those, put it right there. Now we subtract. This zeroes out, right? That zeroes out. Now, when we subtract negative 2x minus a 6x, this is minus 6x. That means we add 6x, right? So that's going to be a positive 4x because we subtracted a negative. Okay, we need to bring down the next term, 4x plus 4. How many times does x minus 6 go into 4x minus 4? So you just based on the first term. We don't look at the 6. We only look at the first term. X goes into 4x 4 times. So multiply that, 4x. Negative 6 times 4 is negative 24. So we have, again, subtracting 24. So subtracting, that means we add. We have a remainder of 28. So that means when we divide this polynomial by this, the answer is x plus 4, plus we have a remainder of 28 x minus 6s. There's 28 x minus 6s. It's like a fraction. X plus 4 plus 28 x minus 6s. So you could have 0 as a remainder, and it divides real nice and evenly. If it doesn't, you end up with something like that. And so you have to be able to do both of those. So let's do an example to where they give it to you in function notation. All right, so they may say, since we deal with function notation, f of x equals 9x squared plus 6, and g of x equals 3x minus 1. All right, so we give us two different functions, and it says find f of x divided by g of x. F of x divided by g of x. All right, so we just set that up. 9x squared plus x. Now here's where it gets tricky. We're going to put 3x plus 1. I'm sorry, minus 1. Minus 1. But I want you to notice something here. We have 9x squared, and then it goes straight to the constant. When we divide this, we need 9x squared, but there's no x's. We need to put the 0x term in there. When we're dividing, we can't skip any terms. See, when we did these over here, we had an x to the third, an x to the squared, and an x. The constant was 0. This has x to the squared, an x, and a constant. This just has the x squared and the 0. So that's the same thing as 9x squared plus 0x plus 6. And it's important to have this 0x in when you're trying to divide by binomial. You need all of those in there. So let's look. How many times does 3x go into 9x squared? Well, when divide 3x by 9x, you get this. So 3x, so that's 9x squared minus 3x. Because we multiply negative 1 times 3x, we get the minus 3x. Okay, so when we subtract that zeroes out. We'll subtract 3x. We'll subtract a negative 3x, that's a positive. So now we have 3x. And we bring down the plus 6. So when we bring down the plus 6, we'll look at how many times does 3x plus 6 go into 3x plus 6. I mean, minus 1 going to 3x plus 6. You only look at this first term. So 3x goes into 3x one time. Take 1 times that, 3x minus 1. When we subtract, this is 0. But 6 minus a negative 1 is 7. So that means when we divide by 3x minus 1, we end up with 3x plus 1 plus 7 3x minus 1s. Plus 7 3x minus 1s. We got a remainder of 7 3x minus 1s. Right? And you sit there and say, why do we do this? Well, if you go back to the old way of dividing, when we divided 6 into 41, let's say that goes in there 6 times 36, 5. So that means when you divide 41 by 6, the answer is 6 plus 5/6. There's 5/6 of another one. Because 6 times 6 is 36, and we're 5/6 the way from another 6. Because there's a remainder of 5. So it works the same thing with polynomial. Whatever you're dividing by is the denominator of your fraction in that. So this is taking you back to some old school long division, but we're doing this with polynomials. So it's important to do the practice problems on this because it's probably been a while since you've done a whole lot of long division. And especially when you're talking about dealing with X's and Y's and stuff inside of your division. So, all right. So our lesson summary talks about the steps. So here's the steps. Number 1, divide, right? That's the first thing we do is divide. Divide that in there. 3x goes to 9x squared 3x times. All right. Number 2, you multiply. After we figure out the 3x, we multiply that times this and put it underneath. That's the third step is subtract. All right, now we subtract whatever we multiply. Subtract this from what was above it. 4, bring down. And they have these steps written in your lesson summary. So if it's not written very well here. So the next thing I do after I subtracted is I brought down the 6. All right. And then you repeat. Repeat until you run out, which we ran out after 1 repetition. That's as far as we made it. All right. So that's important things. Follow these steps and then look for missing terms. Missing terms are important. We were missing a term in there. I'm going to highlight it in orange there. So we didn't have that in the original. So you have to fill in the missing terms. If we had x to the 4th minus 1 and we wanted to divide something into that, we would need to divide it into x to the 4th plus 0x to the 3rds plus 0x squareds plus 0x's minus 1. That's what we would need to use underneath our division symbol. Fill in those gaps for any missing terms because they're there. They're just zeros. So we want to make sure and keep those in the problem there. Keep those in the problem. So that is lesson 4.01, polynomial long division. 4.02, we're going to look at some theorems of algebra. This is our theorems of algebra lesson in 4.02. All right, so let me see what all the fundamental theorem of algebra. Okay, so for the fundamental theorem of algebra, talks about the solution to the quadratic equation. We can use the quadratic formula, which we've learned previously, by completing the square, by factoring or grouping. We've done all of that. If the value of the discriminant, remember the b squared minus 4ac, if that's a perfect square, then you know you can factor it. You'll have whole numbers that you can factor with the discriminant. But see, so they review some of the factoring, determining zeros. And the fundamental theorem of algebra is helping us figure out the zeros of an equation. And what we learn at, if it's a x squared, then the fundamental theorem of algebra tells us there should be 2 zeros. If it's x to the 3rd, I should have 3 zeros. All right, if it's x, it only has 1 0. whatever the highest exponent is tells us how many zeros the equation can have. All right. So if you have an x to the third, you're not going to find 5 zeros. They don't exist. There's no such thing. So the number of x-intercepts could be equal to zeros. Now, sometimes some of these zeros may be complex numbers. You may do that quadratic formula, and some of them have I in it because it has a square root of -1. Those will not show up as an x-intercept because those do not graph. So they could be some complex zeros. Right? If you have those end up like 2 plus 3i and 2 minus 3i, those are complex zeros. When you do that quadratic formula and something like that, these will not show up as x-intercepts. These are imaginary zeros, but they count as 2 of the zeros. So if we're solving an x to the third equation and we end up with zeros like this, those are imaginary, but there's going to be one other zero that you'll find because there are 3 altogether. That's the fundamental theorem of algebra. It tells us how many zeros that you will have is based on the highest exponent. All right. So the other thing we want to talk about is the factor theorem. The factor theorem. And the factor theorem helps us figure out what all factors they are. So when we divide, let's go back to this here, the factor theorem. If we divide this by x minus 6, and we divide this equation, and we ended up with a remainder, that tells us that x minus 6 is not one of the factors of this. The way we'll figure out it's a factor is if you divide this x minus 6 into this equation and you get a remainder of 0, that tells you it is a factor of that function. So that's how the factor theorem helps. If you divide this into there and get a remainder of 0, it's a factor. If you don't get a remainder of 0, then it is not a factor. So that is helps us out there. So that's kind of the remainder theorem in there. The fundamental theorem of algebra tells us the number of zeros. We can use that remainder theorem to tell us that if there's a remainder, then that is not going to be a factor in there. If the remainder is 0, that is one of your factors in there. So the remainder theorem. Let's see. So our lesson summary for 4.02, we're all talking about theorems here. So the fundamental theorem of algebra generally states that the degree of the polynomial, whatever degree it is equivalent to the number of zeros, both real and imaginary, that there are in there. All right. So the fundamental theorem of algebra tells us that this is going to have 3 zeros. Any equation, if we have f of x equals x squared minus 3x minus 28, we know automatically there are 2 zeros because this is an x squared. All right. So we can find all of that. The factor theorem states that the first degree binomial is a factor if the remainder, when divided into that, is 0. So the factor theorem says if we divide x squared minus 3x minus 28, and we say, okay, we're going to divide x plus 7. If we do all of that and it turns out the remainder is 0, x plus 7 is a factor of that. If it ends up with a remainder of 10, that is not a factor of that. So that helps us to know the factor theorem on there. And then the remainder theorem is when the opposite of the constant form of the binomial substitute, the result is the remainder. So this says that if we take, here's what the remainder theorem says. Let's say that we do this division and the remainder is 10, right? I'm just pulling it out. I don't know that the remainder is 10. I haven't done this. I'm just saying, let's assume that is. So the remainder theorem says since this is x plus 7, so x would equal -7 in this case. It means if we take this, which is this equation, and we substitute -7 in there for x, and we solve it, it will end up 10. Whatever the remainder is what that will equal if we take the opposite. X plus 7 means we take -7 and we substitute it into the function. It will equal 10. if that's what the remainder is when we divide it. Kind of cool, kind of all fits together. So if it is a 0, if it has a factor of 0, if it has a remainder of 0, x plus 7 has a remainder of 0, then that means negative 7 is going to be one of our x-intercepts. That will be a 0 of this function. When you graph it, you will have into that. And it also means when you substitute negative 7, it would equal 0. If this is a remainder of 0, it will equal 0. So lots of cool stuff with the 3 theorems that we have in there. So I'm going to leave it at that. You guys need to do the practice in these lessons. Do those practice problems as it shows you that. Use these theorems. See if you can get the answers it's looking for. See if you can do the division and get the same answers that they're getting in the division problems with the long division. Like I said, I don't expect we'll have class the rest of this week because I'm supposed to be getting chemo somewhere, either in the hospital or at the oncologist office. I don't know, but I'm supposed to have chemo for the next several days because they finally got my biopsy back and went, whoa, you've got leukemia. It's like, yeah, you told me that a month ago based on the blood test, but for some reason they had to wait till they saw the biopsy before they believed it, I think, because they've been treating it rather casually until suddenly they got the biopsy results back. So, all right. Hopefully you guys are all done with Unit 3. You should have had the test completed yesterday, starting Unit 4 this week. If you got any questions, hang around. Otherwise, I'll let you go. Have a great week. Have a great Thanksgiving if I don't see you again before then.